Hello everyone. So in this lecture we will be again discussing one more simulation for building this recursive tree. Again we would be building our recursive tree with the help of same thing, whether to select the current element in the knapsack and whether not to select the current element in the knapsack. So what we are doing over here is, this is again the function which will be returning the maximum value which we can get out of the given elements. This value is a pointer or reference to my value array. This weights is a pointer reference to my weights array. This 10 is the weight which my knapsack can hold. This is the current value in my knapsack, and this is the current index currently I am sitting on. So I am starting from the last index, if you would have noticed, and in the previous lecture I was starting from the initial index. So how do I simulate that whether do I select the element or not? So what would I be doing is that, what is the weight currently of the current index I'm sitting on? It's 4. So if I select the element, so what would I be left with in the knapsack? I would be left with a weight of 6 then, because I have already put this much weight in my knapsack. And what would be the value currently in my knapsack? I would be adding the value this 25 to it, and I would be decrementing my index. So what does this subproblem say? This subproblem says that I have dealt with my last element. Just tell me, starting from 0th index till this index, how much more can I add to my knapsack? So this is the way I will be simulating when I select the element to put the element in the knapsack. So how will I simulate if I do not select the element to put it in the knapsack? What would I be doing is that I would be sending the same values to my subsequent recursive call, but I would be decrementing my index. Now what does this mean? This means that I have dealt with my last element starting from 0th index till this element. Just tell me how much more weight can I add to my knapsack. So what does these two values mean? These two values means that currently my knapsack can hold a weight of 10, and currently the value my knapsack is holding is 0. The same way I am currently sitting on index 4. So if I choose this element to put it in the knapsack, so what would I be doing? How much my current knapsack can hold now? My knapsack can only hold a weight of 6. So what does the weight of my index 4 has? It has a weight of 7. So I would be subtracting it from whatever my knapsack can hold. So if I subtract it, I would be reaching over here k and p minus 1, 40, 3. How did this become 40? By adding 15. This 15 I am talking about, this is the value of my element currently at index 4. So this is a base case. And why is this a base case? Look, because my knapsack can now hold nothing over here, because it has already gone in negative. What does this negative say? That the weight I have put in, or the total weight of the elements I have put in my knapsack, that weight is more than my knapsack can hold. So I cannot go beyond this, and hence I would be returning my int min over here. If I do not choose the element present at index 4, then what would I be doing? I would be saying, okay, just tell me that I have dealt with the index 4 and 5 starting from index 0 till this index 3, and currently my knapsack can hold a weight of 6, and currently it has a value of 25. Just tell me how much more can I hold. That's what this subproblem signifies. So what would I be doing? I would be again recursing for two branches. One branch would be to include the element present in index 3, and one branch would not be including it. So can you see how are we actually building our recursive tree over here? So the way of building this recursive tree is a bit different. So I highly recommend you to just branch out for each and every subproblem over here as well, so that you can actually compare what we are doing in both the recursive trees, in the previous recursive tree and in this recursive tree. You will come to know about the distinction, that how we are approaching the algorithm, but the algorithm in both the cases is same. Only just way to simulate the algorithm is a bit different. So in the next lecture we would be again discussing about the optimization of this algorithm with the help of dynamic programming, and we will see how do we approach it with the help of tabulation. So till then, thank you.